Hello guys, a very good morning to all of you. This is our fourth lecture on carbohydrate chemistry. In our previous lecture, the third lecture, we have discussed some easy tricks to remember the ring structures and chain structures of monosaccharides. In our today's lecture, we'll discuss three topics: the formation of glycosidic linkage, the formation of oligosaccharides, more especially the disaccharides, their some properties, and the concept of reducing and non-reducing sugars. Now, let us discuss what is glycosidic linkage. Glycosidic linkage is a bond formed between the hydroxyl group of two monosaccharides unit in a disaccharide or oligosaccharide. We can say that glycosidic linkage is the bond present in the oligosaccharide. Instead of disaccharide, we can say that glycosidic linkage is the bond present between the monomeric unit in a oligosaccharide molecule. We'll discuss glycosidic linkage by taking the example of disaccharides. Now, let us take the example of maltose. Maltose consists of 1 unit of alpha D glucose, this is alpha D glucose, and 1 unit of beta D glucose. This is the beta D glucose unit. Now, this is the carbon number 1 of alpha D glucose, and this is the carbon number 4 of beta D glucose. Now, glycosidic bond will form between these two hydroxyl groups. There is an easy trick. Always remember, you have to link these two hydroxyl group and you have to remove one water molecule from this. First, let us link these two hydroxyl group and let us eliminate one water molecule from here. Now we have eliminated one water molecule from here. Now only an oxygen, this oxygen will remain in this structure. Therefore, we can modify this structure. Now we can modify this structure like this. This is the modified structure oxygen. This is the glycosidic linkage. Now we'll discuss about the nomenclature of the glycosidic linkage. This glycosidic linkage in case of maltose is present between carbon number 1 of alpha D glucose and carbon number 4 of beta D glucose. This is the carbon number 1 of alpha D glucose, therefore alpha 1. This is the 4th carbon atom of beta D glucose, therefore beta 4. Alpha 1 to beta 4 glycosidic linkage, or you can write like this: alpha beta 1 to 4 glycosidic linkage. Now let us take another example. Let us take the example of sucrose. Sucrose consists of 1 unit of alpha D glucose. This is the alpha D glucose, and this is the beta D fructose. 1 unit of alpha D glucose and 1 unit of beta D fructose. Now we have to again link two OH group between alpha D glucose and beta D fructose, and we have to eliminate one water molecule. Now link these two, eliminate one water molecule. It will be like that. It will be like that. The modified structure, let me complete. The modified structure will be like this one. Now for alpha D glucose, this is carbon number 1, therefore alpha 1. For beta D fructose, this is carbon number 2, therefore this linkage is alpha 1 to beta 2 glycosidic linkage. Alpha 1 to beta 2 glycosidic linkage. What will be nomenclature of this disaccharides? I have forgot to tell this. This is alpha D glucose, therefore alpha D glucopyranosyl, because this is pyranosyl ring. This is pyranose ring. For aldehyde, for aldose sugar, this is pyron ring, therefore alpha D glucopyranosyl. Again the linkage is 1 to 4. Then for fructose, for ketose sugar, the ring is furan ring. This is again beta D glucose. For aldose sugar, again pyron ring, therefore beta D glucopyranoside. Therefore nomenclature for maltose will be alpha D glucopyranosyl. Linkage is 1 to 4, again beta D glucopyranoside. And for sucrose, this is an aldose sugar. The ring is pyron ring, therefore alpha D glucopyranosyl. Alpha D glucopyranosyl. Again linkage is 1 to 2. Then fructose, beta D fructose. Fructose is furan ring, therefore beta D furanoside. This is the trick for the nomenclature. This is sucrose. Now let us take the example of lactose. Lactose consists of 1 molecule of beta D glucose and 1 molecule of beta D galactose. This is beta D galactose, this is beta D glucose. Now we have to remove 1 water molecule. For removal of the water molecule, just link this 2 hydroxyl group. What will be the modified structure? The water molecule will eliminate it. This will be the water molecule. After removal of the water molecule, the modified structure will be like that, a zigzag structure in the case of lactose. Again, for beta D galactose, this is carbon number 1, this is carbon number 4. Therefore, this is carbon number 1 of the beta D galactose, therefore beta 1, and this is the 4th carbon of the beta D glucose, therefore beta 1 to beta 4. Glycosidic linkage, or you can simply write it as beta 1 to 4. Glycosidic linkage. Beta 1 to 4 glycosidic linkage. And nomenclature will be beta D galactopyranosyl. I will not write this time, read it with this one. Beta D galactopyranosyl 1 to 4 beta D glucopyranoside. Let us discuss few important informations from exam point of view regarding this maltose, sucrose and lactose. Maltose is the hydrolyzed product of starch. When we take product containing starch, then in our oral cavity there are salivary enzymes that digest or hydrolyze starch into dextrin, and dextrin again digested to form maltose. Now, maltose is mostly used in brewing industry for fermentation of barley, fermentation of paddy, like this. Therefore, it is also known as malt sugar, as it is used for malting or fermentation. Therefore, it is known as malt sugar. It is largely used in brewing industry. This is one important use of maltose. Then, sucrose. Sucrose is the normal cane sugar. It is also known as invert sugar. Now, why this is known as invert sugar? This is sucrose. Let me give 1 minute. This is sucrose. For sucrose, the optical rotation at equilibrium is 52.5 degree. It will be 52.5 degree, but when it will hydrolyze, it will produce 1 unit of glucose and 1 unit of fructose. This is glucose. Suppose this is glucose, this is fructose. 52.5 degree optical rotation means it rotates plane polarized right towards right direction. This is the right direction. This is glucose, this is fructose. Glucose is dextrorotatory. It rotates plane polarized right towards right at an angle of plus 66.5 degree. And fructose, it rotates plane polarized right towards left at an angle of minus 92 degree. So on hydrolysis, sucrose gives glucose and fructose units, and both, and one rotates right towards right, and fructose rotates right towards left. That is in opposite direction, in invert direction. Therefore, it is known as invert sugar. This is an important question from exam point of view. Now, lactose. Lactose is also known as milk sugar. It consists of 1 unit of beta D galactose and 1 unit of beta D glucose via beta 1 to 4 glycosidic linkage. Now, you may have heard the term lactose intolerance. Some of you have the problem of lactose intolerance. Now, what is lactose intolerance? When some people consume dairy product, generally mostly in large amount, like raw milk or any other dairy product, butter, ghee, cream, they may face digestion issue. There may be formation of gas, stomach pain, vomiting, bloating of stomach, like this. It is due to the lack of production of sufficient amount of an enzyme lactase that breaks down this beta 1 to 4 glycosidic linkage to produce glucose or galactose. Due to the insufficient amount of this lactase enzyme, now lactose, milk sugar, will remain in our stomach system. This is an oligosaccharide. Our digestive system cannot absorb this one. Our digestive system can absorb only monosaccharide, that is beta D galactose, beta D glucose. But there is insufficient amount of enzyme, therefore some amount of lactose remain in the stomach, and it will cause this lactose, the symptoms of lactose intolerance. Always remember, lactose tolerance is not actually milk allergy. It is not allergic symptom. It is only due to the production of insufficient amount, due to the production of insufficient amount of the enzyme lactase that breaks the beta 1,4 glycosidic linkage to produce beta D glucose and beta D galactose. Now, how to overcome the symptoms of this lactose intolerance? To overcome the symptoms of lactose intolerance, you have to consume milk product in small quantity initially, and gradually you can increase, you can enhance the amount, and you can also go for lactose free milk. Nowadays lactose free milks are also available in the market that contains this lactase enzyme artificially, and therefore in such packet of lactose free milk, actually this galactose and glucose are present in the free state, but lactose is absent. These two are present in lactose free milk. Or you may go for consumption of probiotics. It also helps in the digestion of milk product. Now let us discuss one important concept, that is what is reducing sugar and non-reducing sugar. When in the carbohydrate, the anomeric group, that is aldehyde or ketone group, is present in free state, then it is known as reducing sugar. Here for maltose, the anomeric carbon atom is present in free state. This is the anomeric carbon atom. It does not participate in bonding. You have to look for the anomeric carbon atom. But this one is the free anomeric atom, the first carbon atom. This is present in free state, and this is present in this takes part in bone formation. But here in case of sucrose, here in case of sucrose, both of these anomeric carbon atom, this one and this one, takes part in bonding. Again, here in case of lactose, this is the free anomeric carbon atom, and this takes part in bonding. If there is only one free anomeric carbon atom, here there is one free anomeric carbon atom, at least there should be one free anomeric atom for the reducing property of carbohydrate. Here this is the free anomeric carbon atom for maltose. For galactose, this is the free anomeric carbon atom. Anomeric carbon atom means aldehyde or ketone group relate to the same structure, you can understand. But here in case of sucrose, this one is anomeric carbon atom, and again this one is anomeric carbon atom. Both takes part in bonding. If there is free anomeric carbon atom, then it is reducing sugar, and if there are no free anomeric carbon atom, both anomeric carbon atom takes part in bonding, then it is known as non-reducing sugar. Now why reducing sugar? This is the free anomeric carbon atom. In free anomeric carbon atom, there are lone pairs of electron. Therefore, it can donate this lone pair of electron to metal ion. This is the oxidized, suppose this is ferric ion, the oxidized state of iron. When it will react with sucrose, in sucrose there is lone pair of electron. Sucrose donate, when it will react with maltose, not sucrose, it will react with maltose or lactose, then or any other, say any other reducing sugar, where anomeric carbon atom is free. As anomeric carbon atom is free, there are lone pair of electron, it will donate lone pair of electron. Therefore, the oxidized form of iron, or say any other metal ion, will reduce. It will convert to Fe2 positive. Due to this reducing property, it is known as reducing sugar. And for non-reducing sugar, say sucrose, they are all the two anomeric carbon atom, both anomeric carbon atom takes part in bonding. There are no lone pair of electron. Therefore, when it reacts with higher metal ion of a higher oxidation state, say Fe3 positive, it will remain Fe3 positive. It will be not reduced, therefore non-reducing sugar. So we can conclude that reducing sugar are the sugars with free anomeric carbon or lone pair of electron that reduces metal ion of higher oxidation state into lower oxidation state. And in case of non-reducing sugar, there are no free anomeric carbon atom that takes part in bonding, so there are no lone pair of electrons. Therefore, they cannot reduce metal ion of higher oxidation state into lower one. Therefore, they are known as non-reducing sugar. So, in our today's lecture, we have discussed about the formation of glycosidic linkage, formation of oligosaccharide, a few important informations from exam point of view about sucrose, maltose, and lactose. And we also discussed about this one, the concept of reducing sugar and non-reducing sugar. And I forgot to mention two important information from exam point of view. There is one disaccharide known as Cellobiose. This is important from competitive exam point of view. Cellobiose consists of 2 units of beta D glucose, and it is important from diagnostic point of view. It is used for the diagnosis of inflammatory bowel disease. You may face this question: which sugar is used, which disaccharide is used for the detection of this one, inflammatory bowel disease? This is Cellobiose. It is consists of 2 units of beta D glucose, and the linkage present is alpha beta 1 to 4 glycosidic linkage. Again, another important example of disaccharide from competitive exam point of view is trehalose. You may face this question: which disaccharide is present in insect blood? Or mention one oligosaccharide. Mention on one oligosaccharide that is present in insect blood, that is trehalose. Trehalose consists of 2 units of alpha D glucose, and the linkage present here is alpha 1 to 1 glycosidic linkage. And this is all about for today. In our next class, we will discuss about the properties of monosaccharides, and if time will allow, then we'll also discuss about the polysaccharide. Thank you. This is all for today.